The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees.
I'm Charles Hanskat. I've been involved in liquid containing structures for, 35 years. I have been doing design, construction, and evaluation of liquid containing structures. And I've been a member of ACI 350. I think I started probably back in 1988 when we were first looking at developing a code. We were taking our not new report, but our existing report, non-mandatory document, making a code. I was actually chair of ACI 350 when we presented the first code to TAC, got it through the TAC review, public review, and then for publication in 01. Since then, we've had 350.6. Just to let you know, ACI 350 is very close to celebrating its 50th anniversary as a technical committee with ACI. And I think that's quite a milestone. We've been a very active committee. I'll let you know, we not only do the code, we have a construction specification for tightness testing to evaluate the liquid tightness of structures. We have a hazardous materials guide, which gives you input in terms of what you need to do when you're storing hazardous materials. Our 350.3 is seismic design. When we first got into writing a code for ACI 350, we found that ASCE didn't have the information in ASC 7 that we were really looking for, that we needed for design of liquid containing structures. So we actually developed the loading side that typically is left to ASC 7 and put it in our own document. We maintain that document. Since then, ASC 7 has actually picked up on many of the things that we put into 350.3. Then we have a 350.4 document that is kind of a guide to design of liquid containing structures. There's helpful hints on things that are needed when you're designing a liquid containing structure. And what we're going to talk about today is 350.5. This is the next number. You can see we went .1, .2, .3, .4, .5. And it's a specification. Why have a specification? Well, the code is a code. It's a code that's made for the designer. And it's not appropriate for contractors. Though I have to admit, I do see engineers who put into their specification that the contractor needs to meet the requirements of 318. Contractors aren't designers. There are some construction provisions in 318, but mostly the document is based for the designers. And that's where we came when we developed our code 350-06. So we decided we needed to have a specification for the environmental engineering structures. And basically, these are tanks. Liquid containing structures, that's a nice formal way to say it, but they're tanks. They're holding liquid, or liquid is flowing through in some way. And the specification is specifically and entirely intended to the contractor. All the mandatory aspects of a specification are for the contractor. So then people say, okay, well, 301's out there. Why don't you use an ACI 301 specification? Why does 350 think they're so special that they have to have their own? And so you look at it. What's 301 for? If you look at the title, it's a specification for structural concrete. But when you go through it, if you really read it, it's for buildings, predominantly. And it parallels ACI 318. We did our whole code in 350 because 318 code was not adequate for design of liquid containing structures. It may have been for the strength side, but not for the long-term durability. When we design tanks, we're talking 50 to 100-year lifespan of these tanks. So 301 parallels 318. 305 is for structural concrete for liquid containing structures, and we look at our code requirements and then what does a contractor need to know from those code requirements to get the job done for a tank. And this may be obvious to many of you, but there's a lot of people that do design of buildings that may not really think about it. But Liquid containings aren't the same as buildings. I've been involved with tanks that have been 70, 75 feet deep. If you think about just a 30-foot wall height full of water, the load, the live load from that water on the floor at the lowest level is about 2,000 pounds per square foot. Those are loads that I don't think you really ever see in a building structure. So we have higher loads. We have dynamic loads. The water's flowing in and out. Certainly in seismic, we have sloshing. A large mass of the contents are being carried by the structure of the tank. And this is a gallery, a very large water treatment plant. But you can see we have a lot of big pipe. For some reason, they like to run pipe through walls so it can get into the inside of the tank. This is about a 30, 35 foot high wall that's intended to be entirely liquid tight through the service life of the structure. And there's no pumps here, but you may actually have a pump gallery that's right next to your particular structure that you're getting dynamics. We do wastewater treatment where there's treatment equipment that has large torques that happen on the structures. So very, very different than the types of things that you see in a building structure. We also have constant exposure to aggressive environments. We have certainly liquid, and then some people say, well, water, that's not aggressive. Well, actually wetting and drying in the water-air interface can be very aggressive towards the performance of the concrete. We also have a lot of potable water that, as you're making the potable water, there's treatment chemicals that can have a lot of impact in terms of either attacking concrete or potentially causing corrosion. So we have specific requirements for containing liquids. And then the chemicals, the treatment chemicals. Also, we can deal with wastewater treatment that is aggressive just by the wastewater. But our 350 document can also be used for industrial processes, where we can get some very aggressive acid conditions or alkaline conditions. And this is a water treatment facility, but you can see varying water lines, wetting and drying, submersion, full submersion. These are conditions that you don't see in a building, and that's why 350 has the code, and that's why we have to have the specification for 350. And you can see here a little bit of equipment, beams across. There's generally, this one I think has a track that goes underneath. But we got a lot of things associated with building tanks. It's not as simple as a lot of people may suspect. We're also very sensitive to cracking. If you look at a through-wall crack, 5 mils and greater will leak. Water is very good about finding any potential way through a concrete wall section. And if you talk to contractors who have done buildings and they go and do a tank, the first tank that they do, they learn that some things are a little bit different, that you can't tolerate the wide cracks that you may be able to tolerate in a building structure. If you go to 224, ACI 224 is on cracking. I think you're looking at on the order of 15, 20 mil crack is an acceptable crack width. That would be horrendous for us. We would have water coming through that section, especially with the high fluid pressures that we have. You talk about the pressure, it's said 2,000 pounds per square foot as a load, these high PSI pressures from that hydrostatic pressure. And this is what the owners don't want to see. This is another tank. This is a gallery in between, and it's kind of like a little swimming pool here because this tank was actually part of it was designed per ACI 318 instead of 350. And so it cracked and it leaked, and the owner doesn't like that. So our specification, our code deals specifically with the things, the details that need to be done to make the structure relatively durable for the exposure conditions and relatively small, at least small cracks so that we don't have major leakage. And there are things that we do in liquid containing structures that you really don't see in a building structure. Circular tanks. If you look at 318, the pre-stressing provisions, the basic provisions are okay, but there's things when you start working in a circle, which is a very efficient structure for a liquid containment because you're generating direct tension in that section. But 318 doesn't really think about things being circular or really even three-dimensional. I think probably the most three-dimensional thing you get in 318 is a two-way slab, and even that's pretty flat as far as I can tell. So we have circular tanks with internal tendons. It has a common strand system and anchorages, but the details that you have to be at liquid tight, protected against the exposures that we have special provisions. We also have wrap pre-stressing, which is not done in the building industry. And you basically take a high-strength wire and wrap it around the tank, make it like a barrel has the rings. Well, we do that on a very large scale with pre-stressing to hold that tank together to balance the water forces pushing out. We also use Shotcrete. 318 doesn't directly deal with Shotcrete. We have a lot of structures that do use Shotcrete. Now, 318 ultimately, hopefully within the next 3 to 6 years, will acknowledge that Shotcrete is a viable material. We were a little bit ahead of the curve and put things in our code, and we also we do have in our specification, we deal with Shotcrete. So here's an example, a circular tank, large diameter. This has a dome roof. So we also deal with shells. Dome shells are specifically covered in 350. And these walls may be cast walls. They typically are pre-stressed either vertically or with a steel shell inside. And this one has a significant amount of Shotcrete that's used to make up part of that wall. And here's wrap pre-stressing. You basically take a high-strength wire, you attach it, and then you pull it under tension around and around and around, laying it in place. And that way you eliminate some of the friction forces. So it's different than the pre-stressing that you see in 318 or 301, the specification for that comes as a result of following 318. And here's Shotcrete. In this particular case, it's being used on a tank to encase wires. But basically, Shotcrete is pneumatically conveyed concrete. You project it at a high velocity, and you don't need a form. There's no form up there to hold that concrete in place. It's basically, it sticks in place. It's consolidated by the high impact of the Shotcrete hitting the wall, and you don't vibrate it. You wouldn't even try to vibrate it in a vertical wall like that. And we cover Shotcrete in our specification because we use it. So if we compare 350.5, that's our 350 specification, to 301, we're very similar in layout and organization. We don't necessarily want to reinvent the wheel. 301's certainly good for buildings, and so we do have larger cover requirements because of the exposure conditions. That's a little bit different than you see in 301. We certainly look at the material requirements for concrete that's used in liquid containing structures because of our exposures to chemical and liquids. We include Shotcrete. We also provide more protection for pre-stress reinforcement. If you look at unbonded tendons, we have used the most stringent requirements and actually gone a little bit above that you may find in a 423 specification. We have also the protection for wrap pre-stress reinforcement is in our specification. The specification doesn't address any responsibilities for anybody on the project but the contractor. How many people here use a 301 spec? So, and you know that that's for the contractor, right? So we do have checklists. And if you use the spec, you know the checklist. But what's different about the checklist from the actual specification provisions? The checklist is not a directive to the contractor. Basically, the checklist, we have mandatory and optional checklist items. They're kind of an appendix. They're kind of here to help the specifier what I say serve as flags. These are things that you need to look at when you're writing your project specification that need, areas that need to be addressed. If we write a spec, we can put in a default value. That may be appropriate, but we may say unless otherwise specified in the spec, and if it's unless otherwise specified, that's a flag to you, hey, maybe I need to look and specify something different. And I'll give you some specifics. But the mandatory checklist is work requirements, specific qualities, procedures, materials, and performance criteria that we don't define in ACI 350.5. So we don't give you a default value because we know that you as the consulting engineer will look at that and put the appropriate value in your contract documents. So the mandatory items, at least the way we expect it to work, is the engineer will look at the mandatory items, go through every mandatory item and make sure that that's addressed in their project specification for a specific project. So in our view, you must include those. If you're using the 350.5 spec, referencing it, that's something that's the duty of the engineer. And this is an example of mandatory checklist items. They follow the text of the spec in the document. But here, we expect you as the engineer to indicate splices on the project documents. Drawings or contract documents, you may have it in text in some form. The engineer specifies the grades, types, and sizes of reinforcements. We can't give a default value that works for every project. You need to look at your project and decide what's right. But we do have the optional checklist items, and these are the things I mentioned. If you read through a spec, you'll see unless otherwise specified. That's usually a flag, what we call trigger language, that you should then find a checklist item that matches that back in the back. And these are choices, things that may be considered for your particular project, but there are things that are optional checklist items that don't apply to many projects, and so you don't have to do anything with that. But you do, once again, tailor it to a particular project and look at the alternatives. Here's an example. Indicative taper ties will be permitted, or if you could in your spec actually require it, or if you want water stops on through ties, various things. Specify if earth coats would be permitted or required. So these are all optional things. If you have a formwork design, as a specifier, do you want to specify that the calculations and drawings have to be signed and sealed by a licensed design professional? These are just examples. We have several pages of optional checklist items. There's only about half a page, maybe 3/4 of a page of mandatory items. So there's not a whole lot of those mandatory, but the optional are there. And to be honest with you, a spec doesn't have a commentary. So we actually sometimes use that checklist as a flag, as a way to put some text in to help to explain to the engineer what we're trying to get to in a particular section. We use the 3-part format, which is typical of 301, a CSI format of general, products, execution. And this is the first 6 chapters of 350.5. Those of you familiar with 301, you'll see that the first, I think it's only the first 5 chapters are the basic parts of what we're doing in liquid containing structures. The general requirements, formwork, reinforcement. This one's a little different, joints and accessories. When I get called in to evaluate a job, one of the first things that I look at is were the joints properly executed. Leakage happens all over the place, but not properly detailing, specifying, or building the joint, a movement joint, can be a distinct problem in getting a tank to be serviceable liquid tight. And we're going to have a presentation. Kyle later is going to talk to you about our provisions for joints. So we're a little different than 301 there, but then we get into concrete mixtures, handling, placing, constructing. Those are all very similar to 301, but we've tweaked it for our particular liquid containing structures. Then the next 4 chapters are what I call special aspects of liquid containing structures. We talk about architectural concrete, mass concrete. Those are actually in 301 also as specialties. But we then add internal post-tension concrete. And remember I talked to you about circular. When you go circular, you're going to have some different provisions than what you would get out of the normal 301, 318 combination. And then we have a specific section on external pre-stressed wrap concrete tanks. This is basically the consensus process. We work on committee balloting. We then go through TAC review. This is a standard mandatory document, so it went through a public review and then approval by the standards boards. All this took years and years. You know, committee time is a little different than normal time. It's kind of like the pilot says, I'm going to take off in 5 minutes, and half an hour you're still there waiting to take off. Well, committee time kind of runs that same way. And our current version is 2012. That's what Reza indicated earlier. It's out, it's in publication now, available for use. We are, as with all technical documents, or most technical documents in ACI, constantly revising. So as soon as you finish a publication and you don't sit on your laurels and expect it to last for 20 years, we are now looking for our next version of our spec. We will look at what 301 is coming up with. 301 should likely be out in 15. Don't take that to the bank. I can't guarantee that 301 will come out in a particular date. But the next one, we're looking at the next version of 301, which should be available for us to review internally, at least within hopefully 6 to 12 months. And then we also will look at our next version of 350, so that the 350.5 does follow on to what will be the current version of the 350 code. And don't take that it's going to be done in 15. That might be wildly optimistic. I don't know. But it takes a long time to develop a code. So just in summary, the current document is based on the current 350 code, which is 350.06, and it's also based on 301-05. When we put this together, you know, it takes years to get it out. So 301-05 was the current version when we were actually looking at putting together our final full ballot for the document. Liquid containing structures are certainly different than building structures, and that's why this specification and our code are really in need in the industry. The specification is geared entirely toward, the mandatory provisions are all for the contractor, but there are the checklist items that the specifier needs to look at. And I would encourage any specifier to read entirely through the spec, because that's what contractor is going to be expected to do. I think it would be wise for you to know that as you go into the project. And we talked to mandatory and optional items. So that's the presentation.